Welcome. The way that we are interacting with data is changing. It is changing, and it's not being transactional anymore. It is more conversational, thanks to the large language models and the capabilities that they are bringing to us. Together with Mark today, we will be talking about how you can build and scale a RAG application within your organizations. If you are not aware what RAG means, it's a great session for you. It will be a starter slides that we will be sharing. If you are an expert as well, Mark will be sharing with you lots of details regarding how we can scale it to thousands of indexes. Having said that, RAG is a retrieval augmented generation, which means you are using a large language model to reason over your data. And within the last 18 to 20 months, we have seen lots of implementations of it. And all of us experimented different methodologies, different approaches. But eventually, if you look at it in a very, very simplified format, actually there are two things that you need to make sure it is working. The first one is the data ingestion, meaning let's say that you have millions of documents, even thousands of documents that you want to chat against. And in an enterprise, normally this is the way that you are leveraging an LLM, right? So if you are an organization, you want responses to be grounded with your data versus anything else that is available in the internet. And this is why you need like a data ingestion engine to bring all this information into a search index. This is the first step. And within this first step, you need to do a couple things. Due to the limitations of a large language model and its contextual window, you need to do some chunking. Chunking means, let's say that you have 100 pages of a document or 1,000 pages of a PDF, doesn't matter. You basically need to cut it down into smaller pages because an LLM could understand in the range of kilobytes, which is normally a couple pages of a document. This means that if you have 1 million documents, you need to find a way to chunk those documents into the smaller subsets that you will be capturing and storing within your indexes. The second step for it is vectorization. After you create those chunks, you create vector embeddings associated to those chunks. Very short, very concise. Vectors are numerical representation of your data in an n-dimensional space. And in the early days of RAG, where we started with this journey, we thought that, hey, you will do the chunking, you will do the vectoring, and then you put everything into a vector index. Then the life will be so simple. You will get all the answers that you are looking for. The second part of this equation is the data retrieval. So after the first step, once you ingest all your information into an index, you need to retrieve this data. Basically, you need to find the relevant chunks within millions of documents that you have. Due to, the limitations of an LLM, you need to ingest it 5 or 10 documents at a time, basically 5 to 10 chunks at a time, which means that you cannot send your entire 1 million documents, but you need to find a way to identify the right and the relevant documents within all those, and then send it to an LLM. It will generate a response together with the user prompt and the system prompt. So keep in mind, two steps, data ingestion and the data retrieval. And we have seen hundreds of customers, including ourselves, trying, experimenting, learning, ideating, and so on and so forth. And basically, we got lots of learnings. I categorize them under those 4 buckets. But if you ask, there are maybe multiple more. But in general, the vector embeddings are not enough. This is number one key learning that we get. Vectors are great for understanding unstructured documents, extracting information from unstructured data, but you need more than a vector embedding to create a high accuracy, 95% plus accuracy kind of a RAG if you are willing to implement one. The second one is the data preparation really takes time. When I say data preparation, it is the steps of data ingestion, including chunking, including vector embedding creation, and you might need to do it multiple times because the way that you chunk, the chunk sizes, the way that you overlap this data is all kind of an experimentational thing that you need to try and understand which works for you and which works better for your use case and the scenario. That means you need to get prepared to make sure that you are building the ground for multiple iterations. It is not just you build once and then it will work. You will build once, you will iterate, you will learn, you will advance, you will iterate, and so on and so forth. So you need to make sure that you build that foundation in a way that you can iterate easily, test, analyze, evaluate, and build on top of it. And this requires to start small. Like I've seen some customers who created vector embeddings for 1 million documents and trying to understand how they can improve the accuracy. It is better to start small, start understanding the use case, even asking your users what type of questions you want to get a response for, and start from there. And with all these complexities as well, it is really hard to justify the business value to your business stakeholders. Like when they start talking about return on investment, it is hard to explain how you will be justifying all this investment that you are doing versus an accuracy gain of maybe like 70%, 75%. And most of the time, these business stakeholders will be a little bit more concerned again for the hallucinations and so on and so forth. So in general, within those 2 years, what we learn is RAG is hard. It looks simple to start, but if you want to build high accuracy infrastructure, a solution, you need to iterate over time, which means RAG optimization is a journey. And I'm looking to this journey from 3 different dimensions. You need to make sure that it is justifying the cost, meaning return on investment, the time that you build it, the time that is required to iterate each and every time. All of them I'm looking as costs. The second part is the quality, how you will improve the quality, and how you will measure the quality, and how you will understand which step you need to take action to improve the quality. And the last one is the performance, right? The performance means it is a conversational space. It's a chatbot that you are building one way or another, and you cannot expect users to wait 10 seconds, 15 seconds, 30 seconds to get a response from a chatbot. So you need to make sure that there's a very small latency. It will work really efficiently and effectively. So which means now, if you look back to the initial model that I mentioned to you, like data ingestion and the data retrieval, now you need to add more and more on top of it to make sure that you are building it at scale for the relevant capabilities that you are after. I will give you a couple thoughts. These are not the exclusive everything that you might think of, but I think these are really good starting points that you can think about. And you can evaluate whether those techniques, whether those capabilities will help you improve your RAG quality over the time, and you achieve the goal that you are after faster. The first one is, I mentioned about vectors, right? And then within AI search, we have more than the vectors now. And if you look at it, we have two layers. We have level 1 ranker level, and then we have the level 2, which means in the first one, we retrieve the information from your indexes with a hybrid search option. Hybrid search means we are not only using vectors, but as well we are using keywords. Keywords are really good at more semi-structural data. Let's say that you have products and product descriptions. Keywords are still performing very well compared to the vectors. If you have specific terms that you are using within your organization, like abbreviations and so on and so forth, we have synonyms that are working with keywords that are really good to understand your own language and try to extract information accordingly. For vectors, as they are trained through as your data, as LLMs are trained through the large language models, through the data available in the internet, they normally don't understand your abbreviations, and they will not be able to retrieve you back the relevant results. That is why using them together, keyword and vector search in a hybrid way, is really helping boosting the performance. The second part is the semantic ranker. The semantic ranker, what it does is it looks to the original user query, understands the context, and then it compares it with the response that you are getting from the hybrid search. And then it re-ranks based on the initial question, understanding which chunks are much more better relevant for your needs, and then they will be providing you a much more accurate outcome. So the way it works is we use all these two techniques together in a way that we use a reciprocal ranking fusion technique, which helps understand vectors, keyword results, we generate the top 50 out of it, and then the re-ranker reshuffles them to see what are the much more relevant within those top 50. And as you can see here, we kind of analyze it with different data sets, and the hybrid search together with a ranker is outperforming with all these different data sets. So this is an option for you, like without any hassle. Basically, what you can do is by enabling a hybrid search, enabling a semantic ranker, you can get up to 10-15% additional accuracy over the retrieval data that you are working on. The second part of the equation is how you can simplify the data ingestion. Like, if you look at it, again, very broad, you have multiple things that you need to consider. You have some AI skills, which could be like OCRing a PDF document. It could be translating speech to text. It could be, entity recognition, language understanding. It could be even an LLM in between trying to understand and summarize your documents. And then you will do the chunking, you will do the vector embeddings, and then you store it within your indexes. And the other side of it, after you do the AI skills, you will as well capture all these documents and the extracted text within the indexes. And also, like, the way that we are looking to it is, again, to simplify things. We have a capability which is called integrated vectorization. Instead, you will build all this pipeline with all the separate APIs of your own or the APIs that you will choose. You can use our integrated vectorization option. Basically, within the integrated vectorization, we give you a capability to pick and choose which AI models you want to use, which embedding model you want to use, how you want to do the chunking. Basically, those are parameters, and you don't need to think about how this pipeline performs over time. We will take care of the rest. The next thing that I want to talk about is, again, about cost. So, of course, cost have multiple perspectives, multiple dimensions. There might be multiple different things that you can do to simplify and optimize the cost. I'm just providing you one example here that is pretty much aligned with improving the cost, especially for large data sets. If you have terabytes of data sets, and if you want to optimize them, we have a capability which is called compressed vectors. Within compressed vectors, what we do is, once you create your chunks with the vector embeddings, you have options, right? You have Ada, you have Hugging Face, you have Llama, and all the others. And then they have dimensions. Like, if you take Ada as an example, which is the OpenAI embedding model, it has different dimensions, including 1536 and 3072. So when you create your vector embeddings, it will be a long float 32, which will occupy lots of space. So what we do with compressed vectors is we give you an ability using binary quantization or matryoshka layers, where you can use those techniques to shorten the size of the vector embeddings without losing or compromising from the accuracy. Basically, what we are doing is, instead of float 32, we capture the embeddings as 1 bit, which means it's 32 times reduction of the size. So basically, which means you will invest 32 times less amount of space for storing the vectors. And if you look at it from the accuracy perspective, we use the technique together with these matryoshka layers, where you will only lose 2% accuracy within the retrieval systems. So by gaining 32 times of space, you are only giving out 2% of the accuracy. These are a couple things that I want to touch. And next, I want to ask Mark to come to the stage. He is the VP of data science in AT&T. They use those techniques, they use these concepts, and scale out RAG into a really very, very complex use cases and scenarios. Thank you, Mark, for coming, and over to you.
Thank you, Ben. All right, so that's a lot of great background, and I have to say, before I go through this, I wish all that was available a year and a half ago, because we've been doing the heavy lifting, doing a lot of that stuff manually, as probably you have done as well. But now all that stuff is in AI Search products, so check it out. I'm going to talk a little bit about examples. I want to talk a little bit about scale. Let me talk a little bit about what we're doing at AT&T. So our enterprise GenAI platform, we call it Ask AT&T. We have 100,000 employees and contractors on it. We've done 150 million external API calls. We're doing about 1 billion tokens a day, external as well. And we have 55 use cases in production. I would say there's probably triple that that are in staging right now that we're kind of bringing on. A lot of that stuff is RAG, because RAG is a little bit basic on question and answer type stuff. Now, what you don't see here is we have a lot of internal API calls as well, as we host our own embedding vectors. So there's probably, when we're doing heavy ingestion, it's not uncommon that we'll have 200 million API calls internal as well for all the embedding vectors also. So let me tell you a little bit about the use cases, okay? So these are some of the top use case categories. Of course, question and answer, asking questions. We call that Ask Docs, asking questions of documents at AT&T. That's RAG, right? So it's almost every single business unit I could think of, HR, finance, network. They all have their own documents. They all want questions there. Customer care is huge in that regards. So that's a big one. Coding is huge as well, and we're trying to basically use agents and RAG to basically look at the entire software development lifecycle. So it's not just when you're coding, like in GitHub Copilot. We want to kind of help them before the coding, right? What are you trying to do? What are the things you're enhancing? Let's automatically write the user stories. Let's write the code for it. Let's write the test scripts, and let's write the software vulnerability check, right? So think about the entire lifecycle there, and we have agents involved in that one. And then we have the green one on the bottom there, classifying, creating content. And this new one, Ask Data. So when we think about Ask Docs or question and answer, it's mostly unstructured, right? We want to talk about structured data as well. I'm going to talk about that one in a second. But on RAG, we actually announced this in our second quarter earnings. Our care agents, or our care representatives, are now 33% faster, because they can get the answer, right? So before, when they would do a search, if they don't know an answer, they type it, they get the 10 blue links, so they have to kind of click on each link. So what do we do now with RAG? We generate the answer, right? So you get the answer automatically, right? So it's huge on time saving there, and that's how you get the savings, right? Ask Data is a good story as well on structured data. AT&T, I'm proud to say, is now #1 in the world on Ask Data. We recently topped Google and IBM and Alibaba and Stanford there. If you haven't heard about this, is the BERT benchmark, okay? Now, what do I mean by that? That's text to SQL, right? So now I'm asking questions of databases, right? There's a little bit of RAG there because you have to kind of figure out which database are you asking a question of, which tables do you extract. There's a lot more going on there, but text to SQL is the next thing. Because at the end of the day, we're trying to answer questions, right? Whether the question is in documents or data, you want to pull it out there, okay? So think about that as well. So and Ben covered this really much more detail, but when you think about what do you get with ChatGPT, right? Well, you get your question, and you get the large language model, but it doesn't help you on your internal stuff, right? So what do you have to do as your own company? You have to teach it about your own stuff, right? For us, we have to teach it about AT&T, and RAG is a huge way to do that. So all that stuff in the middle, that's where the RAG comes in. Of course, we want to make sure it's role-based access. So just like you kind of protect who has access to this data, it should also be who has access to these documents, right? So you want to add role-based access most likely on there as well. To do that, you might do some other things like we do. So a lot of the things that we're asking questions of, it's code. We want to make sure we're not kind of inadvertently taking copyright code. We want to do that consciously. So we pop that up as well. We give it, here, this one looks like it's code produced, but hey, this one looks like it's copyright. So you might want to consider that also, okay? Of course, once you do that, you go to the large language models, and then you can get the answer there. And you might use some feedback also. So that's the basic construct. This is kind of what our Ask AT&T looks like. You see the public knowledge, that's the straight large language model endpoint. Thanks to Microsoft, we had a nice private secure endpoint there. And we have multiple language models that we can use. The thing in the middle is AT&T knowledge. So that's going to be our Ask Docs, asking questions of documents, asking questions of data. And then we also have something we call My Files. So that's kind of, really don't need to worry about role-based access. It's your own stuff. You can put it in there. You do RAG. You ask questions of data. Code interpreter type stuff you would see in there as well. So this is our web interface. We also have it on Teams and also have it on a mobile app as well. All right, so let's talk about grading, okay? This is where, when Ben says RAG is hard, okay? It's hard because out of the box, anybody can do a POC, a proof of concept, right? You'll get something that's basically working. but are you getting the most value out of it? So what you want to do is you want to create a leaderboard, okay? And you can't see all the numbers here in the columns, but these are different measures. You're doing LLM as a judge. You might do BERT. You might do what % of the time did I get my top answer in the top 1, 3, 5, 10 chunks, right? All those things. Now, each of these rows is different configurations, okay? Let me show you, and we've graded 2,500 RAG pipelines, right? Because we do a lot of this, because there's a lot, and I want to show you, like, what is the difference? Now, that same chart, if that same table that you just saw, this is the same thing, and each one of these bars is the accuracy result, okay? So using LLM as a judge, that's what these are. Each one of these is a different configuration, and what do we mean by that? It's a different chunking size. It's a different overlap. It might be a different embedding vector. It might be a different re-ranker at the end. It might have the hybrid search. It might have all sorts of stuff, right? So basically, any white paper that was out there, we basically tried it on these things as we were learning this thing. Okay, now out of the box, you notice we were at there, okay, that's like 76%. It's not uncommon when you're out of the box RAG might perform that, right? Now all these things, you have to tune it. You have to try all those different things. And Microsoft's trying to pull all that into AI Search, and we're going to have to kind of grade their latest and greatest. They just came out with this week. We'll put it on the chart as well, on the leaderboard, right? Now, you see, we went all the way over there to the left. That's about a 10% improvement. Production, you could see, 85. I think we're actually above 90. I don't have the latest one here. But that's kind of where we're at. And you might say, well, Mark, why didn't you choose the top one? Okay. Now, you can barely see these little circles. You see these little circles on there? That's the latency. Now, if you think about a problem longer and you make a more advanced retriever and you do other stuff, you can get it right, okay? You just do smarter things, but it's going to cost you. And if you're in customer care and you're trying to answer a question, you can't afford that, as an example, right? So we chose that one. It was a good balance of accuracy, and it's a good balance of latency there. So that's kind of why we chose that one there. But each of these things, this took a long time to kind of do that and tune these things. Now, depending on your use case, you might say, that 10%, is it worth it? Now, depending on your use case, how many kind of calls you're doing, how many things, if it's a really high volume thing, it might be worth it. It could be millions of dollars if you kind of calculate it, right? So be careful, kind of think about the business side of it as well is what I'd recommend. All right, so Ben showed some results. These are the same things that he talked about, okay? So each of these bars, within a given grouping is vector search, hybrid search, semantic re-ranker, and this last one called enrichment, okay? Enrichment is when we enrich the chunks, okay? Now in our case, for this particular example that I have here, we're putting in the title and the summary, kind of on every single chunk, because when you ask a question, you want to pull out the right document there, okay? Now, notice that you get improvement on all of these, and the x-axis there, top 1, top 3, that's how many chunks, okay? Because you want to say, did I get the right, now we've hand-labeled this one in this case, so we know the exact chunk that has the answer, and what we're showing here is what % of the time did I get that chunk that has the answer to my question, okay? So that's a bit manual to kind of do that, hard, but for important use cases, you probably want to do that, right? So this is the % of the time I got it. You notice the last one here, if I threw in 10 chunks, I put in all of the tricks along with the enrichment and 92.6%, okay? But you notice that it's a big difference in terms of the performance there. All right, so we did that example, and we were kind of high-fiving ourselves. We said, we nailed this thing. We got the best pipeline. Let's go give it to everybody in the business. And we said, well, let's give it to our network and field operations folks. We said, here's this thing. We've got it automated. It's point and click. You don't need to do anything. Just load your documents. So they did that, and they came back, and they said, hey, this thing doesn't work. I said, what do you mean it doesn't work? It works phenomenal. And they said, no, it's not giving me the answer. And I was like, well, show me some examples. It turns out their documents, since it's field and network, it's loaded with pictures, okay? And when they were asking a question, the answer was inside of pictures, okay? And that one example, you could barely see it there, but if you want to know where is the fiber output number, it's only in that picture, and it's the last 2 digits of that where it's pointing on the tape there, okay? So how do you answer that? Okay, so all of a sudden we had to say, now I need to kind of make sure for this use case, because it's loaded with pictures. In fact, 43% of all these documents had answers in the pictures, okay? So we had to redo it. Now, at the time, if you just tried some of the multimodal embeddings, didn't work very well, right? So we had to try a different approach. So we had to basically pull it out, and I'll show you the different approaches in a second. But the bottom line is be careful of your documents. Know what you're trying to answer. Check out, are the answers in pictures, and you might have to do something more advanced. Now, here's just an example. This thing that you see on the right here, that's called a T handle, okay? And the question is, what is this T? Show me what's a T handle. If you just do text, doesn't know it. But if you kind of pull it out of the picture, then you can kind of get the answer there. Or this one, right? If you wanted to kind of understand, this is one of our boxes there, and you ask another question. What are the lights on this ONT? Okay, and if you had a picture, you could basically answer that. If you're extracting, right, so what we did is we had to understand every single picture, and what we tried is 3 different approaches, okay? So here you see, this is our own view. Now this is several months ago, but basically it's a good, better, best, okay? So if you just tried multimodal embedding, now we've seen some really promising stuff by some of the folks here this week. There's new multimodal embeddings out there that you can basically retrieve off of whether it's text. You can retrieve the picture or the text. But at the time, it wasn't working very well. We tried the clip embeddings. Didn't work very well, right? So I put that as kind of as good. You kind of get in the ballpark, but if you want anything detailed, didn't really work. The second one is you basically take every single picture and you try to summarize everything you see in the picture. So you could use GPT-4o, you could use GPT Vision, or your favorite other kind of large language model that understands picture. So you write the summary first, and you index that, and you try to extract the summary. Once you get the summary, you pull off the picture as well, okay? So I'd say that one is better. But you notice that's another step. That's a pretty expensive step. Starts getting more costly now, right? Now, the one that works the best is kind of the same thing. I look at every single picture, I extract the summary, and then I retrieve it. I retrieve the picture, but then I do it one more time. So because I take the actual question and I interrogate it with, let's say, GPT-V or GPT-4o once more on the actual picture, okay? So that one was actually gave us the best performance, but it's a bit costly. But anyway, all that said, the use case now works like a charm, but we're very interested in revisiting the first one, I'd say, with some of these multimodal embeddings or some of these new models that understand pictures as well. All right, so let's talk RAG pipeline. So when you get these things, you got to go to production, right? So you do your normal dev stage in prod. I think we actually have multiple stage and multiple devs, but I'm just showing you some of these here. But you notice that I've highlighted a few things here. You add up all of them, it's 2,700 RAG pipelines. Now, not all of those are in production, but we're testing all those things, right? So we're testing all those things, figuring out, then we'll lock in one, and that'll go to production there. And notice the other thing that when we first did this, these vector stores struggled, I would say, with size. Right now, it's not an issue anymore, but we're terabytes in size on the vector stores as well. If you get millions of documents, you're going to want something that's really robust, and you've got a really large vector store. Now, this is latency. So we're, certainly when you're in these things, you're trying to figure out where is my latency at, because I want to get the response back as soon as possible. This is kind of the latency of the vector store, and it's basically, the bottom line is it's not the limiter in most cases. Unless you're using a very small language model, that's going to be the limiter. It's not going to be your vector store. These things are in the milliseconds, and this is a bit old as well. I think it's probably even faster than that now, okay? But you want to look at it, because you're going to have things that you want rapid response. If you think about some of the voice RAG right now, you want super rapid response, right? It's super important, right? You want the real-time voice, you want the real-time RAG. You really can't afford more than a second, in my opinion, on voice RAG, so you want to look at that closely. Now, let's kind of come back. At the end of the day, all that is kind of cool things and grading stuff, but at the end of the day, it's about answering questions, okay? Now, I put this together, and it's probably not perfectly accurate, but I wanted to kind of talk about questions themselves, okay? Now, at the bottom, think of this pyramid here it's like if you almost think of it as the percentage of type of questions do you get, okay? So the larger the bottom of the pyramid, that probably has the most questions, right? It's basically getting the answer that's stated in the documents and pulling that out. Vector search does fine for that, okay? Now, the other thing that Ben talked about is the hybrid search. That's adding keywords, right? If you want to get almost like all the documents that are relevant with super high recall, you got to add the hybrid search, right? That's super important. This other one, this graph search, okay, this is when the documents have some kind of connectivity between the different portions of the document, or you want to ask your questions like this: which rate plan is better, A or B? Okay? And you can think of like you almost want to do like two. You want to break that down. You want to do like two queries, and you want to grab the chunks and you want to fuse them together. You want to have the large language model of that. Okay, so that's a question that's there, right? But you may or may not get the right answer unless you do something like that. But it's an important question that does pop up. Now, this next one on the pyramid, it's one that we're seeing, and this is where you want to do almost retrieval with a bit of math, okay? So tell me the sum value of all contracts that are expiring by next June, okay? So I could get the contracts that are expiring, but then I have to say, what's the sum of that, okay? So there's different ways you could probably do that. So we call that as a combination of ask docs in our lingo and ask data. So the ask data is like, okay, now I need to kind of do SQL on what I've extracted there as well. So using extraction in conjunction with the indexing lets you answer more questions. Now the top one is something that you may have to deal with in your company. It's what if you have more than one vector store? What if you have the SaaS vendors now, Salesforce, ServiceNow, Workday, you name it, they may all have vector stores as well. Okay, so you don't have the luxury of maybe having one vector store. So now maybe most use cases you're okay, you're in that vector store, but sometimes you have questions that need answers from multiple. So now all of a sudden I have to have a router to figure out, I got to pull this from there, I got to pull this from there, I got to route the question, right? So that's something else that you want to think about, but there's definitely questions in that category also. All right, so I'm going to let Ben come back up, and we'll do a little bit of a summary, and we'll wrap it up.
Before going to the summary, Mark, I think you shared lots of great insights. And for the ones who want to start today, who wants to work in a RAG pipeline, who want to make it sure that they scale as big as yours, what would be your suggestions, when or why or how they should start?
Yeah. Steal, I would say. What I mean by that is borrow notebooks, borrow examples. I think Microsoft has a ton of them. There's a ton of stuff out on GitHub. But you'll get basic concepts, and you can learn that way. But you'll get a proof of concept. Don't overlook the grading piece, right? So figure out the eval. So kind of make that kind of part of your process, right? So you could say, okay, I know I'm retrieving it, but how often am I getting the answer right? And there's different ways to do that. You could do the hand labeling of them, or there's more advanced things. You'll probably start generating your own questions and answers, so you'll take the documents, so you'll be doing that as well. But get your eval in place, and then use the resources of the web. Talk to Ben, ourselves. I'm happy to chat and share all of the different things we've found as well.
Great. So what about, I have a kind of an idea saying that before starting anything, just go and talk with your end users and understand what type of questions they will be asking. Because what we are observing is, regardless how good you build your own data set, it might not reflect the reality of the actual users, what is in their mind. You also showed a great example with the images. Mm-hmm. I don't know, what do you think about it? Is it a good approach to go and interview a couple of your users?
Yeah, for sure. I mean, it's like anything. We always say data science is a team sport. You've got to have the business involved. In fact, when you're setting up your truth set, the more you can get out of them is hey, I need to make sure you're answering these questions. I got to get these right. That's super important. But then one other lesson learned that I'd say we found is production might look quite a bit different than what you thought you were doing. Okay, so your truth set when you started the users may not be doing that. And the perfect example of that is we had these, really great questions with multiple words, and it was really a question. And most of your users, they're not thinking about that. They're thinking old school. So they will start with a keyword. They won't even put a question, right? So all of a sudden, the hybrid search helps with that. But really, look at what they're actually doing is important. Or you might want to help them, right? So we actually try to help, and we try to maybe autocomplete, turn it into a question if we can, or we try to state it, state it as a question, you'll get better answers. But you'll find a lot of times your retrieval is, hey, it's not there, but if you rewrite it as a question, most times you get it. But it's super important to not only have eval on your training, but you have to have on your production as well.
Yeah, it's a great point. Actually, we also announced today a new feature which is called query rewriting. Actually, what it does is, as Mark mentioned, like your users might ask anything. We are all trained to find the right words to search against, right? We are not trained over the last years for a question to write properly. And the way that you write the question also impacts the retrieval accuracy a lot. So what we did, knowing all these challenges, we come with an idea which is called query writer. Basically, what it does is you ask as a user, and then we use a small language model in between to understand what is the actual question, and then we interpret 10 additional questions associated with the initial, and retrieve all the information that are relevant to those 10 questions instead of just the one that the user is asking. We have seen as well lots of additional accuracy gains with that approach. Thank you so much, Mark.
Sure.
I appreciate your time.
You got some takeaways here. You want to summarize the takeaways?
Yeah, absolutely. So thank you so much again. So to recap, you might use many other techniques. I just want to touch to those. As I mentioned in the earlier, like RAG is hard. It requires multiple iterations. But as well, everyone is learning and sharing with each other. Every day you will see a new announcement, a new GitHub repo. I think it is always good to be on the edge, understanding what is happening there. But in general, if you ask me, what are the 4 key takeaways if you are building a RAG, just keep in mind, vectors are not enough. You might use multiple additional things so that you will have an advanced retrieval technique or multiple techniques to find the right information, right chunks within the entire data corpus that you have versus only relying to the vectors. The other part is, vectors are a little bit more like a black box. You basically ask a question, you retrieve a response, but you cannot manipulate it. So you can use additional features that we have within our vector space, like vector weighting. You can use the filtering, and as well as synonyms within the keywords to make sure that you can as well interpret or manipulate the results to get the best which is relevant for your needs. The second one is, as recap, as data preparation takes time. Yes, you don't need to build your own pipeline. Start with integrated vectorization. Even start with simpler low-code, no-code tools that we provide within Azure Foundry and as well within our Copilot Studio to learn, to exercise, to iterate. And then you can start customizing it with the additional code. For the justification of the ROI, try the compression techniques. Understand if you can reduce down the data sizes and as well reduce the total cost of ownership. And don't forget, I think it's maybe stating the obvious, but scaling requires multiple iterations. So start small, set the expectations right, iterate, improve, and build your RAG at scale over time. Having said that, thank you so much for your time. We have a couple more additional sessions that are relevant and related to search and RAG and how you can retrieve information from large data sets of yours. We have Graph RAG tomorrow. We have a couple more if you want to take a picture. Thanks again for your time. If you have any questions, you can come here. I think we will close the session now, and we can answer your questions after the session. Thank you.
Thank you.
Thank you.